Good afternoon, I am Razon, and what I will discuss today is myths about antenna and antenna design. Myths about antenna introduction. So there are myths, distortion, lies, and urban legends surrounding antennas than any other aspect of amateur radio. So my goal is to clarify some popular myths while still providing useful antenna information. Too often, old wives' tales regarding antenna are passed down as a gospel to young radio amateurs when they are actually incorrect theories. So, in the following slide, we will examine some of these myths to see how true they really are. So, myth number 1. Open line feed lines radiate more than coax. So this is incorrect. A balanced open line or a ladder line feed system will radiate no more than coax when properly installed. A field intensity measurement around your feed line will prove this. If your feed line radiates or antenna is out of balance and needs to be corrected. Myth number 2. One-half wave vertical antenna like a J-pole do not need radials. This is false. J-pole is worst case situation for examining unwanted feed line radiation. So all of the common mode current provided by a poor fed system flows over the coax, shield, and mast in the case of J-pole without radials. So the mast and coax are usually vertical mast and coax shield. So myth number 3, all antennas need a ground. It is false. Some of antennas need a RF ground to complete the other half of the antenna. Examples, high frequency and very high frequency or ultra high frequency mobile antennas use the vehicle body as a counterpoise or ground plane. So many antenna are self-completing and do not need an RF ground. So here are some examples that do not need an RF ground. Dipole, Yagi, cubical quad, loop, rhombic, and others. Myth number 4. A 5/8 wave antenna has 3 dB more gain than a ground plane. It is a false. The losses in the required matching coil at the base of the 5/8 wave antenna reduce the gain difference of a max of about 2 dB with a perfect ground plane to 0 difference in some installation. Where and how you mount the antenna on your vehicle is important. The 2.85 dB theoretical gain is only for a perfect lossless matching coil and with the antenna over a perfect infinite flat ground plane. Myth number 5. A poor antenna mounted high will outperform a good antenna mounted low. It's true. High is everything. These are not called line of sight bands for nothing. Yes, I know tropo, moon, meteor bounds, and some other forms may not benefit from the height. Myth number 6. The size of the antenna does not matter. False. Because shortened antenna are less efficient. In other words, a comprise of performance bigger is better. Antenna gain is a function of effective aperture or effective area. Myth number 7. If I move to hilltop, my signal will be louder and I will hear better. Not necessarily so. You may have a lower noise level and hear better if you are farther away from noise sources while on a hill. High frequency in the valley floor here and are heard as well as the hilltop. All other conditions equal. The benefit to elevation is the low angle skywave window of two-way reception may be longer, not louder. Line of sight contacts like very high frequency will be expanded. Myth number 8. My hamstick high frequency mobile antenna has a lower VSWR than your large screwdriver, or bag catcher. Perhaps dummy load has a lower VSWR than dipole and more bandwidth. Myth number 9, an inductor is different than a loading coil or a choke. False. They are same, just used in different application. So coiled up wire is an inductor no matter what you name or you call it. Myth number 10, most antennas will benefit from a balloon. True. If you are attempting to obtain particular radiation patterns, directive antenna like a Yagi will produce more predictable pattern with fewer side lobes. Myth number 11, antennas that work for transmitting will be fine for receiving and vice versa. False. Vertical has a low angle of radiation for TX. However, pick up more noise when receiving. Myth number 12, higher gain antennas receives better. Perhaps they may, but not in every case. Direction and polarization of arriving signals and noise constantly vary, and so the relative relationship of each to any individual antenna's response will vary. Myth number 13. So, linear loading is more efficient than conventional coil or lamp loading. False, because if you choose your components carefully, the losses are about the same. Loading of any kind of losses greater than full-size elements. Myths about antenna design introduction. So, antennas are required for a device to connect to the internet via radio frequency. Cellphone, satellite communication, and even garage door opens are all obvious examples. When it comes to today's connected devices, industrial designers and gadget makers like Apple have perfected the art of concealing a vital component, antennas, to the point where they've largely vanished from the view. So here's are the 11 myths about antenna design. First is, antenna design can be put off until after the industrial or mechanical design. The size of the antenna and the size of the PCB ground planes have a big impact on antenna efficiency. A wireless product with a low performance is all too often rejected by network operators due to poor performing antenna. Second is, cheap antenna perform well regardless of PCB size. The size of the ground antenna has a big impact on a cheap antenna efficiency. Since the ground plane and antenna evaluation boards are significantly different size, antenna performance and bandwidth would suffer. It is important to closely follow the datasheet or application notice while using a cheap antenna, and to use a PCB size that's close to the antenna evaluation board. Third is, dipole antenna are always better than monopole antennas. So since dipole antenna are balanced, they have less radiating current on coaxial cable shield. This ensures more reliable performance than monopoles without a significant ground plane to hold currents away from the cable shield. Monopoles, on the other hand, can be smaller than dipoles since the other half of the antennas can be made of a PCB ground plane or metal frame without losing output. Number 4 is, a well-matched antenna will perform well. So impedance matching is just half of a story when it comes to antennas. Mismatch losses, matching, network resistive losses, and radiation efficiency all affect total antenna efficiency. Although a strictly resistive match will have a low mismatch loss and high return loss, the resistive losses would drop the overall output. Number 5 is, matching network should be avoided. If you don't have option for an impedance matching network, your antenna can be severely detuned, requiring more PCB spin to install the required matching network or adjusted the antenna. Number 6 is, matching network should always be used. So matching network have a backup mechanism in the event of a mismatched antennas. But some systems are better off without them, as the number of devices is estimated to be in the hundreds of thousands. Removing a single surface mount part from the assembly process will save a lot of money. 7. High QR wound inductors should always be used in matching networks. As compared to ceramic or a thin film inductors, high Q inductors have less loss and can have lower transmission losses when using matching networks. However, it's still preferable to use a more lossy inductor. Number 8 is antenna efficiency is paramount regardless of the application of technology. To gain network operator approval, some technologies such as cellular require high antenna efficiencies. Other systems that use unlicensed spectrum do not have antenna specifications, but they still need FCC approved. The FCC, on the other hand, does not have any standards for antenna performance. This ensures that any underperforming antennas can be sold cheaply. An FCC certified device that meets the application requirements. This explains why some items are more successful than others. Number 9, more gain equals less pain. So the amount of energy radiated in any given direction is measured by antenna gain. A more directional antenna would have a higher gain. An omnidirectional low gain antenna is high performance antenna that radiates in all directions. A directional antenna such as a satellite dish can have a gain of 30 dBi, meaning that majority of energy is radiated in one direction. Number 10 is wearable applications should use loop antennas. So since the near field are primarily magnetic rather than electric loop, antenna are generally less sensitive to dielectric losses or detanning than dipoles or monopoles. The body absorbs RF energy and attenuates electric field since it is mainly salt water, which is a lossy dielectric. 11 is low frequency means more range. Lower frequency waves travel more quickly through materials than higher frequency waves. However, lower frequency does not always mean less path loss. It simply means that for the same amount of power to be collected, a lower antenna gain is needed. Here are the question and answer about MIT's antenna and antenna design. This is the end of presentation. Thank you.